Today we're going to look at congruent triangles. Two triangles are congruent if they satisfy any of the following four situations. So we've got the four different situations here, and each one has a different code. Each one has a different code based on the rule that it follows. So the first is SSS, which stands for side, side, side. So that means if we've got three equal corresponding sides, then the two triangles are congruent. So here we've got two triangles. Each of the sides has a corresponding side that is exactly the same length. So because they're the same length, we've got three corresponding sides. These two triangles are congruent. These two triangles are congruent right here. And that's based on this rule, SSS. Three sides are the same. This side matches that one, this matches that, and that one matches that one. The second rule that we've got here, or the second situation, is side angle side, SAS. So two equal corresponding sides, two sides that are the same, with one equal corresponding angle in between them. So the angle has to be in between the two sides. So here we've got a triangle with two equal sides, and there's an angle in between them. Okay, so this angle here corresponds to this angle here, and it's flanked by two sides as well. It's got the same two sides, the same two side lengths next to them. So these two triangles are congruent. In fact, you can see that this triangle has been reflected and then rotated around. So it's been reflected so that this side is over this side, and it's been rotated around to make this side over here. So these two sides are corresponding and equal. These two sides are corresponding and equal, and this angle here is corresponding and equal. And it's only if the angle is in between the two sides. If the angle was over here, it would not guarantee that the triangles are congruent. If the angle was over here, it would not guarantee that the triangles are congruent. It must be in between the two sides. The next rule is angle, angle, side. And this is with two equal corresponding angles and one equal corresponding side. So angle, angle, side. Now, these ones can be in any order. These ones can be in any order. It doesn't, the side doesn't need to be after the angles. It could be, the side could be in between the angles. It could be anywhere. It could be any two angles and any side in the triangles that are corresponding. So here we've got this angle corresponding with this angle corresponding with this angle, and this side corresponding with this side. If it could have been these sides that are corresponding, it could have been these sides that are corresponding. But because we've got one side that corresponds, and we've got one angle here that corresponds and another angle here that corresponds, these two triangles are congruent. So they are congruent. So here, last rule is RHS. So RHS stands for right angled triangle, hypotenuse, side. So we need to have two right angled triangles with equal hypotenuse lengths. So the hypotenuses have to be the same length, and one other pair of corresponding sides. So here we've got the right angles. They're right angled, both right angled triangles. The hypotenuse, which is opposite the right angle. This is the hypotenuse here. The hypotenuse is opposite the right angle, and those two are both the same length. So that means they are those two are corresponding sides, and we've got another side here that is corresponding. So these two triangles are congruent. They are the same triangle, just rotated. I think this one is just rotated right around. So let's have a look at an example. Which congruence test would you choose to test the congruence of these pairs of triangles? So here we've got a pair of triangles here. We've got two angles and a side in the middle of them. Now, so this is 60 degrees here, 70 degrees, 60 degrees, 70 degrees. So we've got these two angles here correspond. These two angles here correspond, and this side here corresponds. So we can see that this sort of, if this is a congruent triangle, it would have been rotated around. So the rule that we could use, we've got two angles and one side. angle, angle, side. That is going to be the rule. Angle, angle, side that we're going to use. And it could have been any side anywhere. It could have been any angle anywhere, because for angle, angle, side, it doesn't matter what order they're in. For this one, B here, we've got two right-angled triangles, and we've got the hypotenuse is given for us there. The hypotenuse directly across from the right angle. The hypotenuse is the same, 15 metres. So we're right there, and we've got another side as well that is the same as well, that is corresponding and is equal. So here we'd use RHS, because we've got a right angle triangle, the hypotenuse is the same, and there's one side that is the same.